Alright, so we're going to start learning about one-dimensional kinematics, the basis of algebra-based physics. So the main concept we need to learn is the difference between speed and velocity, where speed is a measure of distance over time, as opposed to velocity, which is a measure of displacement over time. The difference between distance and displacement is that distance covers the object's entire path of travel, while displacement just refers to the object's final position minus its initial position. So unlike speed, velocity actually accounts for direction. So velocity can be positive or negative, while speed can only be positive. The equation we derive for average velocity is the change in displacement, or final position minus initial position, all over time. And similarly, the equation for average acceleration is the change in velocity, or final velocity minus initial velocity, all over time. Now, acceleration also accounts for direction, so the signs for both velocity and acceleration can be different, or they can be the same, and it determines whether or not the object is speeding up or slowing down. So if acceleration and velocity have the same sign, say they're both positive, then the object is speeding up, but if they're negative and positive or different, then the object is slowing down. There are 6 variables you need to know when dealing with one-dimensional kinematics. You have initial velocity, final velocity, initial position, final position, time, and acceleration. And you are given 3 uniformly accelerated motion equations on your AP equation sheet, starting with final velocity equals initial velocity plus acceleration times time. Then you have final position equals initial position plus initial velocity times time plus 1/2 acceleration times time squared. Then you have final velocity squared equals initial velocity squared plus 2 times acceleration times change in initial position, subtracted from final position. And then we're going to be discussing graphs in relation to time. Now the main thing to discuss with graphs is that in descending order, velocity is a slope of position and acceleration is the slope of velocity. So if velocity is positive, then the slope of position is increasing, and same for acceleration in relation to velocity.
So next we'll be discussing the units you'll be using for average velocity. The equation for average velocity again is the change of displacement over change in time, and that triangle is going to mean the final mass initial. And then x represents the displacement, which is always going to be measured in meters. It's represented by m. And then the t stands for time, which is measured in seconds. So that's going to give you meters over seconds. So that's the units for velocity. And then average acceleration, the equation for that is the change in velocity over the change in time. And so that's meters per second over seconds, which simplifies down to meters per second squared. So acceleration is, the units is meters per second squared. The next one we're talking about falling objects. One of the main things of falling objects is that no matter the mass of the object, the acceleration of gravity will always be the same on it. So on all objects, the acceleration of gravity is always going to be negative 9.81 meters per second squared. So if you can imagine a ball being thrown up and coming back down, that's what most of the problems will look like. In the section where it's going up, the velocity will be increasing because you threw it up, but the acceleration will still be downwards, so it'll be going upwards but slowing down. And then at the very top, because it's going to have to go from upwards velocity to downwards velocity, it's going to be 0 at the very top. Velocity is 0 at the very top. But the acceleration is still downwards and negative. And then when the ball is coming down, the velocity is now negative, so it's coming downwards. And then since velocity and acceleration are in the same direction, it's been going down and speeding up. So the variables for this that you'll see a lot of times is x initial is going to be your initial height that it was thrown from. And then x final is the final height. That could be catching the ball hitting the ground, whatever that bit is. And then the velocity initial is going to be your initial velocity that you threw it with. And then the acceleration will always be negative 9.81 meters per second squared. And next we're going to be talking about things to know for when you're reading the story problems. So at rest just means you have a velocity of 0. So it's not moving, so it's at rest. And next, constant velocity means you have no acceleration, because acceleration is change in velocity, so if your velocity isn't changing, then you have no acceleration. Right or up will normally be positive, and left or down is going to be negative. And then, unless you're told otherwise in the problem, friction and air resistance, you can always consider them as negligible,